Good morning, welcome to CEI. This is Dr. Sekhar, chemistry teacher. Today I will teach the properties of bases. Now, properties of bases, physical properties. You know that bases have bitter taste, because if you take the taste of soap, you will find the taste that is bitter. So we can say that the physical properties, we can say that it has a taste that is bitter, not like acid, because acid we have the sour taste. And soapy to touch, because you know that bases are present in soap. So when you feed soapy to when you touch the soap or any alkali like NaOH or KOH, if you touch, if it is possible, or if you find NaOH or KOH and if you touch, then you will find some soapy feelings. So there are mainly two, which are in taste and soapy in touch. And in case of indicator, now bases can change colorless phenolphthalein to pink. Not like acid, because acid doesn't have any change with the indicator phenolphthalein, but phenolphthalein in case of alkali or base, we find it is color from colorless to pink. Methyl orange, methyl orange, it will be red to orange. And litmus solution, it will be blue. Okay. Then indicator phenolphthalein pink and litmus red to blue and methyl orange red to yellow. So there are indicator, three kinds of indicator I discussed when alkali is used. Next, chemical properties. Reaction with metals. I have written over here reaction with metals. Now metals react with the alkali like NaOH or KOH, they evolve hydrogen gas. Like NaOH or sodium hydroxide react with zinc, it forms sodium zincate and hydrogen gas is evolved. Like aluminium, it forms sodium aluminate, hydrogen. Lead, we get sodium plumbite or potassium plumbite. In case of tin, stannite, sodium or potassium stannite, arsenic, then arsenite, etc. They form salt and hydrogen gas evolve. That is first chemical property of alkali. So let me write the reaction. Twice NaOH plus zinc, we get Na2 ZnO2 plus hydrogen gas. Okay. KOH, same reaction will be KOH plus zinc, we get K2 ZnO2 plus hydrogen gas. Now in case of aluminium, 2A plus 2 NaOH plus 2 water, we get twice NaAlO2 plus 3 hydrogen molecule. So sodium aluminate plus hydrogen gas. Similar reaction with KOH, twice KOH plus 2 water, we get twice KAlO2 plus 3 hydrogen. Similarly, one reaction I am writing lead, twice NaOH plus Pb, Na2 PbO2 plus hydrogen gas. Similarly, twice KOH plus T. If you take the T, we get potassium stannite, K2SnO2 plus hydrogen gas. Then, what's more, let me say that alkali like NaOH or KOH, they react with zinc, aluminium, lead, tin, arsenic, etc. Arsenic I am not showing, it is not very important. They form the respective salt like sodium zincate, sodium aluminate, sodium plumbite, sodium and potassium stannite with the formation or with the evolution of hydrogen gas. Okay. Now second reaction with acid oxide. Reaction with acetic oxide. Now acidic oxide means you know non-metallic oxides are called acidic oxide. So non-metallic oxide like carbon dioxide, sulfur dioxide, phosphorus pentoxide, phosphorus trioxide, hydrogen dioxide, hydrogen pentoxide, trioxide, etc. Several various non-metallic oxides are there, and they all are called acidic oxide because they form acids by the reaction with water. That's why they are called acidic oxide. Now, acidic oxide reacts with alkalis or bases to form the respective salts. Okay. Now let me give one example. Suppose calcium oxide plus carbon dioxide, which is acidic oxide, to form calcium carbonate. Or you can say, suppose calcium hydroxide, if you take calcium hydroxide plus carbon dioxide, we get calcium carbonate plus water. This is lime water. Lime water, you know, class 7 onward you have studied. This is milky. This is milky. This solution turns to milky when carbon dioxide is passed through it, but this milkiness is soluble in excess carbon dioxide. If you pass excess carbon dioxide to this calcium carbonate or this mixture, we get again soluble, again colorless solution in the formation of calcium bicarbonate soluble. So it is colorless solution. So it is colorless solution. Let me say once more. When carbon dioxide gas is passed through lime water turns to milky because we know lime water is a colorless solution and it turns to milky. Milk solution or milky solution is obtained because of the formation of insoluble calcium carbonate. But this mixture is soluble. This mixture again turns to colorless. Again disappears. Milkiness disappears when excess carbon dioxide is passed through it. Why? Because calcium bicarbonate is soluble in water and it forms calcium bicarbonate. So it is soluble in water and it is a colorless solution. So the milkiness disappears or the milkiness is turns to colorless solution. Okay. Now similar reactions I am showing few like nitrogen dioxide or sulfur dioxide. Sulfur dioxide, if we take NaOH plus sulfur dioxide, we get Na2SO3 plus water, sodium sulfide plus water, KOH plus SO3. Suppose if we take SO3, we get K2SO4 plus water. Now sulfur dioxide, acidic oxide, sulfur dioxide, acidic oxide, when they react with alkalis to form the respective salts. If you take only the Na, suppose if you take the magnesium oxide plus sulfur dioxide, we get magnesium sulfide. Alright. Now similarly, if you take nitrogen dioxide plus nitrogen plus NaOH, we get NaNO2 plus NaNO3 plus water. Now twice NaNO2 plus twice NaOH, we get NaNO2 plus NaNO3 plus water. That's why we get a mixture of two salts. Mixture of two salts. Why? Because it is mixed anhydride. It is called mixed anhydride. Mixed anhydride. Mixed anhydride. NO2 is a mixed anhydride because it forms two types of acids, nitrous acid and nitric acid, when dissolved in water. So it forms two types of salts, sodium nitrite and sodium nitrate. That's why we get a mixture of two salts. Again I repeat, I will say once more, because nitrogen dioxide is an acidic oxide, non-metallic oxide, but it is also called mixed anhydride. Why it is called mixed anhydride? Because when it dissolves in water, it forms a mixture of two acids known as nitrous acid and nitric acid. And so these two acids, when react with alkali like NaOH or KOH, it forms two types of salts, sodium nitrate or nitrate and nitrate. NaOH, using NaOH, you get sodium nitrate and sodium nitrite, KOH, potassium nitrate and potassium nitrite, and water. Similarly, phosphorus pentoxide, phosphorus trioxide, if you use the base, you get the respective phosphate or phosphite. Suppose, if you use nitrogen pentoxide, you get the respective nitrates, sodium hydroxide plus N2O5, sodium oxide plus nitrogen pentoxide, you get sodium nitrate. Or if you use a calcium hydroxide plus nitrogen pentoxide, you get calcium nitrate. Nitrogen pentoxide will form nitrate. Nitrogen trioxide will form sodium nitrite. In this way, the reaction takes place with the bases. This is the property of bases. Okay. So, reaction with acid oxides we have completed. Next part, reaction with acid. We know that acid reacts with the bases to form salt and water. Okay, but if you write the base metal oxide, you will get the salt, and if you take the alkalis or hydroxide, if you take the oxides, you will get the salt, and if you take the hydroxide, you will get the salt and water. Now, most common examples: HCl, H2SO4, and HNO3. HCl plus NaOH, we get NaCl plus water. That means acid plus base, salt and water. Acid plus base produces salt and water. So reaction with acids, it forms salt and water. More examples: H2SO4 plus 2KOH, K2SO4 plus 2H2O, HNO3 plus calcium hydroxide, suppose we get calcium nitrate plus water. Alright. Suppose calcium, suppose if we take magnesium hydroxide, magnesium oxide plus sulfuric acid, if we take the base, we get magnesium sulfate plus water. Salt and water everywhere. Suppose if we take zinc oxide plus HNO3 or HCl, we get zinc chloride plus water. If we take copper oxide plus H2SO4, we get copper sulfate plus water in this way. Let me conclude that acids react with the bases or bases react with the acids to form salt and water. Example, we take the base hydroxide, we take hydroxide, we take oxide. If we take the hydroxide, like here the hydroxide I have taken NaOH, CH, these three are hydroxide and these three are oxides. In all cases, we get salt and water. Alright, the next one is ammonium salts. When bases is heated with ammonium salts, it forms ammonia gas. If you heat the mixture of ammonium chloride and calcium oxide or hydroxide, we get ammonia gas. If we heat ammonium salts, means ammonium carbonate plus NaOH or KOH or CaO or COH, any basis it is, will get the ammonia gas. So I am taking one or two examples for heating of ammonium salts. Suppose ammonium chloride plus calcium hydroxide, we get twice ammonia plus CaCl2 plus 2H2O, or if we take ammonium sulfate plus NaOH, we get 2 ammonia plus Na2SO4 plus 2H2O. Okay. Similarly, ammonium carbonate plus calcium oxide, you get twice ammonia plus carbon plus calcium carbonate plus 2 water. So let me conclude. By heating ammonium salts to the bases, it produces ammonia gas. Like ammonium chloride with bases like calcium oxide, hydroxide, or ammonium sodium hydroxide or potassium hydroxide, we get ammonia gas with respective salts and water. Similarly, sulfate and carbonate, they also produce respective salts with the evolution of ammonia gas. Okay, the properties of bases are completed. Today is no more. Thank you so much. If you like this video, please like, share and subscribe. Thank you.